Hello, everyone. My name is George Cortina, and I am an anesthesia resident at Duke University. And I am sharing our work on building an early warning model to predict the risk of post-cardiothoracic surgery patients decompensating and requiring return to the cardiothoracic ICU or CTICU or facing death. Now, the reason that we focused our model on cardiothoracic ICU patients or CTICU patients is that these post-surgical patient populations are at high risk of decompensating, both due to the complexity of their surgeries and also the acuity of their disease as compared to other ICU patients. Now, typically it is our hope that patients undergoing this surgery go through a pattern of admission, perioperative or an operation, to the CTICU, to an intermediate or step-down unit, and then from this intermediate or step-down unit going to home or to other units that are even lower acuity. This Sankey diagram maps the flow of patients that decompensated after cardiothoracic surgery. And as you can see from this diagram, it greatly complicates their hospital stay. This decompensation both increases the length of the hospital stay and also the cost and morbidity for these patients. Therefore, we sought to build a model that would predict the hourly risk of a patient returning to the cardiothoracic ICU or dying in the next 48 hours while they're in these step-down or intermediate units. This model is supposed to run hourly and generate a prediction score, and above a certain score, it would alarm. When this alarm goes off, there would then be an intervention to try to prevent the patient from further decompensating. This model is based on two types of data. First, there would be static or unchanging data for these patients while in these step-down or intermediate units. This would be summary statistics and information from the OR and the ICU, and then demographics on the patient. Then every hour, dynamic data would be updated with orders, lab values, and vitals for these patients, forming the hourly model data set for these models. Preliminary models have outperformed traditional score-based metrics, for example, NEWS and MUSE, which are early warning systems or scores. The model is based on two types of machine learning architecture, logistic regression and gradient boosted trees. Both had AUCs around 0.7 and 0.74, and then AUC-PR is around 0.1, again beating NEWS and MUSE scores. We're currently evaluating the performance of other models based on different machine learning architectures. Additionally, we're looking into new ways to evaluate the performance of these models that would relate to how they would be implemented and used in the hospital. It is our hope for this model to start in a silent run on some floors at Duke University and then move potentially into a tool that can be used to predict decompensation of patients after they leave the ICU. Thank you very much.